Hi, I'm Rhett Jesse, and today we're going to talk about the Metrix 5580 signal conditioner. Now, this same demonstration I'm doing with the 5580, I can do with the SW5580 switch. But today we're going to use the 5580 just to show you that works too. So on the 5580, what I have is in channel 1, I have an SA6200A accelerometer. And that's what you see here. I have this HI903 shaker, this Hardy shaker, set at 1G at 20 Hertz. This is simulating a reciprocating compressor out in the field. So that's what I'm simulating, and it's running. I'm taking data inside. How I have this 5580 set up is I have it set up in a dual path mode, where I have one channel coming in and I have it separated as two acceleration channels coming out. So I have acceleration out of channel 1 in milliamps. This is channel 1 to my left, and I have channel 2 to my right in milliamps. All right. Now, if I was measuring the raw signal in either channel in this mode, I would be measuring acceleration. All right, and that happens no matter what I'm doing in this experiment, the way I've got this set up. What I want to do is change channel 2 into an impact measurement. So that way, and when this is vibrating at 1G at 20 Hertz, we'll see 5.6 milliamps approximately. Because I'm at 1G, it's 100 millivolts per G. The scale factor is 0 to 10 Gs. So 16 milliamps divided by 10 is 1.6 milliamps. Plus 4 gives you that 5.6 milliamps. So that's pretty close to that. And it has to be within 5%, so that's plenty close. What I want to do though, on the second channel, I want to see impacts. And I'm not having any impacts right now. So I want to set this impact channel up so that it works. So let me go ahead and do that in the software. Let me go ahead and connect to it first. We'll do that with this USB cable. You can download the free software from our website, and you can connect to it. And right now I'll go ahead and connect to the device. I've got the USB already connected. And you can see in channel 1 and channel 2 it's set up for acceleration, 100 millivolts per G with a scale factor of 0 to 10 Gs peak. So that's on both of them. So now what I want to do is I want to go over to the impact channel here, and I want to go ahead and enable channel 2 for impact. So channel 1 is where the source of the vibration is coming in, but I'm going to use it for channel 1 will be acceleration, channel 2 will be impact. Now you have to remember how an impact system works. What we do is we time for 16 movements of the compressor, 16 cycles, or 16 compression events. So when you measure those 16 throws of the compressor, if there's an impact, each impact will equal 1 milliamp. So on a scale from 4 to 20 milliamps, 4 milliamps are no impacts, 12 milliamps would be 8 impacts, and 20 milliamps would be 16 impacts. So that's the most you can have. Usually if you have 6 to 8 impacts, you should start looking. More than 8, you should start thinking I should shut down that machine because I have a real problem. Above 12, certainly shut down the machine. But that's how you set it up. But you have to make sure you have everything set up right, and we're going to do that during this demonstration. All right. So I'm going to go ahead and say channel 2 impact enable, and I'll say yes because we have a 100 millivolt per G accelerometer. I'm going to go ahead and enter my password. And I don't want to see that again during this demo, so I'm going to hit that button. Say enter. And what this will do is this will turn on the impact channel, which is going to be channel 2, and you'll see it will drop from 5.6 milliamps down to 4, or right around 4. Should be 4 and very close. I'm going to say get peak, and this will get the baseline acceleration that we're seeing on this reciprocating compressor that we're simulating. All right, and you can see we're not violating any thresholds here. But right now we have 1G, and it's an accelerometer that has a scale factor of 100 millivolts per G. So I should be getting 100 millivolts peak to peak. And that's exactly what I have, is I have 100 millivolts, 102. So it's just slightly off. It has to be within 5%, and that's very good. What I'm going to do now, because that's the baseline vibration I'm getting off of the crosshead, what I want to do is I want to change this to my threshold to something above that. Now, if this was a brand new machine, I'd put it at 200. If this was an older machine, I might put it at 300. So I want to make sure that I really do have energy that's greater than the threshold. So it depends how old the machine is. So a new running machine, 200. Older machine, you'd go 2 times for a newer machine, 3 times for an older machine to set up this initial threshold. Those are just guidelines. You have to look at how your machine behaves and see how the system's behaving to know how to do it best, but that's roughly how you do it. Let's go ahead and put in 150, just for the purposes of this demonstration. I'll put in 150. And the RPM, because I'm doing this and I'm using a shaker, I have to kind of trick the system to make it useful for this demonstration. So instead of putting in a typical machine RPM of 300 or 600 RPM, I'm going to put in 2400 RPM because it makes the math a lot easier for me. Okay, so I'm going to put in 2400 RPM. All right, and 2400 RPM is how many cycles per second. So we just have to divide that by 60 and it works out to be 40 hertz or 40 cycles per second. That's important, very useful for us. I'm going to go ahead and send that now to our device, our channel 2 impact measurement. So if your machine was operating at some other RPM, you'd want to put in the proper RPM. If it's at 300, put in 300. But for the purposes of this demonstration, I'm going to use 2400 just to make my math easier, so when I describe it to you, you understand it. What I'm going to do now is increase the vibration level up to 200 Gs. So we're going to exceed the threshold, but I'm at 20 hertz. So 20 hertz is 20 cycles per second on the shaker. 20 cycles, that's 20 hits per second. Well, my reset time is 0.4 seconds. You can see that over here in the software, 0.4 seconds. So I'm at 20 cycles per second on the shaker. That's 20 hits per second. I'm going to go ahead and multiply it by 0.4 to give me how many hits are in that window. And so comes out to 8. So 20 times 0.4 is 8 hits per second. I'm going to go ahead and increase this to 200. Or 2 Gs, which is 200 millivolts. So I'm going to exceed our 150 threshold. And I'll wait till I get to 200. And I'm at 2 Gs right now. Yeah, so 2 Gs at 100 millivolts per G is 200 millivolts. So, and I had the threshold set at 150. You can see that over here at current values. I'm going to say go ahead and get peak, just to make sure we're exceeding the threshold. And we are. And we're exceeding the threshold at 20 hits per second. That's what we're simulating, this impact event. Well, my window, because I simulated 2400 RPM, is only 0.4 seconds. So I had 16 throws of the piston. I calculated that to be 0.4 seconds at 2400 RPM. All right, 0.4 seconds times 20 hertz of the shaker means 8 hits. And remember, each impact event, as long as you're within the window, is 1 milliamp. Okay, so if you have 8 hits in that window, which we do, you go 8 hits, 8 milliamps plus 4 gives us 12 milliamps, and that's exactly what we see. And you'll see that the vibration is something less than that. So even though we have these impact events going on, the vibration level is less, and that's important. I have this set exactly at 200 millivolts, and it's 100 millivolts per G. 2 Gs is 20% of full scale, so that's 2 times 0.2 times 16 is 3.2 milliamps, plus 4 is 7.2 milliamps, and that's what you see in this window. Typically that won't happen. You can have a mismatch between the acceleration that you're reading and the impact events you're seeing, and that's why you want an impact device, so you can actually see impacting versus just vibration. Let's go ahead and increase the impacts to 30 impacts a second, which would be 12 impacts within that 0.4 second window. Let's go ahead and increase it to 30. Come up. Okay, there's 30 hertz. We're still at 2 Gs. Okay, so we've exceeded our threshold. At 30 hertz, that's 30 impacts a second, times 0.4 gives us 12 impacts per second, or 12 impacts in that window. 12 impacts is 12 milliamps, plus 4 is 16, and so what you see on the meter is 16 milliamps. Okay, and what you see over here to the left is you can see that since the shaker it's reading 2 Gs, you can see over here that it's reading 2 Gs. 2 Gs is 20% of full scale. So 16 milliamps times 0.2 is 3.2, plus 4 is 7.2 milliamps. And we're at 7.0, so it's very close. It's well within a few percentage points. 10% is 1.6 milliamps, 5% is 0.8 milliamps, 4% is 0.4 milliamps. So it's within 0.4 milliamps, so it's down less than 5%. So that's very good. It's half of that, 2.5%. So very accurate. But what's interesting is now the impacting events, that's why we read something different, and that's because we changed the frequency. So that's what we're simulating. If I want to take this up to 20, I can do that by taking it up to 40 hertz. 40 impacts within 1 second times 0.4 gives me 16 impacts within the window. So we'll go up and go up to 40. And now we're getting 16 impacts within that 0.4 second window, and we're driving 20 milliamps. So you'll notice we're still at 2 Gs, which is 200 millivolts per G. So the acceleration hasn't changed, but the impacts events have, because we changed the frequency. Right now, if I said get peak, we're still at close to 200 millivolts per G for the 2 Gs that we have, which is correct. We're right on the money there. And then we're still looking at that 0.4 second window. At 40 hertz, that's going to be 16 impacts. So remember, 1 impact per 1 milliamp. So we have 16 milliamps plus 4, it gives us our 20. So the system's very accurate. You can measure acceleration in channel 1 and impact off of channel 2 quite easily. And so it's perfectly suited for looking at the crosshead on a reciprocating compressor. Thank you very much for watching. Thank you.